87 years, 44 locks, over $1 billion in today's money. One of Canada's longest historic canal systems, carved through some of the most fractured terrain in the country, connecting Lake Ontario to Georgian Bay. So why has almost nobody heard of it? The geography of central Ontario looks manageable on a map. Rivers stretch northwest, lakes dot the terrain, and there's a corridor running from Lake Ontario all the way to Georgian Bay on Lake Huron. Turning that corridor into a functioning waterway was a fundamentally different challenge. The full route runs 240 miles from Trenton on Lake Ontario, northwest through the Trent River, across a chain of lakes in the Kawathas, up to a summit at Balsam Lake roughly 840 feet above sea level, then back down through Lake Simcoe and the Severn River to Georgian Bay. That's roughly the distance from Toronto to Ottawa, but engineered through some of the most fractured terrain in Ontario. Most of that distance is existing water. The difficulty is that none of it connects naturally. Rivers and lakes sit at completely different elevations, separated by rock ridges, rapids, and stretches of Canadian Shield granite that don't yield easily to anything. Linking them into a single navigable corridor meant engineering interventions at every gap. Dams to raise water levels, canal cuts blasted through solid rock, and locks to step boats up and down across constantly shifting terrain. The push came from timber companies and local politicians, not military planners. The St. Lawrence River was Canada's main inland water corridor, running uncomfortably close to the American border. A fully inland route through Ontario, entirely on British territory, would give Canada a protected alternative. But that was a justification layered on top of what was, at its core, a push for commerce. The Trent-Severn Waterway was never constructed as a single coordinated project. There was no unified budget, no central authority directing the whole thing, and no moment when someone drew a 240-mile line on a map and committed to seeing it through. The first lock opened at Bobcaygeon in 1833, built to connect local lakes for timber and steamship traffic rather than fulfill any national vision. A few years later, the Upper Canada Rebellion of 1837 prompted officials to examine the full route as a potential military corridor. Their conclusion? It would require too many locks to move troops efficiently. They quietly stepped back from that idea. But the locks already built were useful, and that became the problem. Settlers wanted more access to the interior. Timber companies lobbied for the next extension. Local politicians pushed for the following section after that. Every new lock opened a little more of the backcountry to navigation. Nobody was constructing a 240-mile waterway. They were solving the nearest local problem, and then the next one. Meanwhile, the rest of Canada was moving in a completely different direction. The Grand Trunk Railway reached Toronto in 1856, while workers were still cutting early canal sections. The Canadian Pacific Railway completed its transcontinental line in 1885. Every decade, the commercial case for finishing an inland water shortcut grew thinner, and the building kept going. The Welland Canal was being deepened. The St. Lawrence Corridor was being modernized and expanded. What the Trent-Severn could offer kept shrinking against faster, larger, more capable infrastructure. The gap was visible to anyone paying attention. Richard Birdsall Rogers became superintending engineer in 1884. Before proposing his design, he travelled to England and Europe to study existing hydraulic lift locks firsthand, trying to understand why similar systems had been dismissed as impractical and whether the skeptics were right. He came back convinced they weren't. Rather than pushing for more conventional locks, Rogers proposed a hydraulic machine that would lift an entire boat, still floating, straight up using nothing but the weight of water acting through a connected hydraulic system. Most engineers told him it couldn't work at the scale he was proposing. He built it anyway. World War I diverted money and manpower and added years of delay to the final sections. By 1920, the last gaps were finally filled, 87 years after that first lock at Bobcaygeon. Through navigation opened in 1922. The total original cost came to approximately $24 million in Canadian currency, over $1 billion in today's money. By the time Rogers' machines were running, Canada's railway network was already more capable than this waterway could ever be. But the engineers had built something extraordinary anyway, and in at least 3 places along those 240 miles, what they built was unlike anything else on the continent. The Trent Seven's three most remarkable structures weren't built to showcase what was possible. They were built because the landscape left no simpler option. Each one is extraordinary precisely because it had no business being built at all. The key insight in Rogers' design was about weight. A caisson, essentially a large steel tank, holding water in a floating boat, displaces water equal to the boat's own mass, which means the loaded tank weighs almost the same as the empty one. Place two of those tanks on opposing hydraulic rams, and they sit in near-perfect balance from the start. From there, the system needs only a small nudge. A modest volume of extra water added to the upper caisson creates a slight imbalance. That caisson drops under its own weight, driving hydraulic fluid through a line that forces the lower caisson upward. The whole exchange covers 65 feet in a single stroke, with no machinery involved beyond the water itself. Construction began in 1896. The Peterborough Lift Lock opened on June 9, 1904, as the highest hydraulic boat lift on Earth and the largest structure ever built using unreinforced concrete, both records at the time of its opening. For passengers on the boat, the experience is unlike most things on any waterway. You float into a steel container, tie up, feel the structure shudder slightly, and then the horizon begins to drop away beneath you. In a few minutes you're at the top, and you haven't heard a single engine. Kirkfield doesn't draw the same attention as Peterborough, but what it does is more important to the route's function. Using the same paired caisson system, it raises boats approximately 49 feet to the top of the watershed. Without it, every boat attempting the full 240-mile journey stalls at the summit. Kirkfield is the hinge the entire system turns on. At the western end, the Severn River drops through rugged Canadian shield terrain toward Georgian Bay. Engineers faced a landscape that no conventional lock could handle cleanly, so they built a railway for boats instead. A massive steel carriage sits on inclined rails. Boats motor onto the carriage, settle into adjustable steel slings, and the entire structure hauls itself up the incline and over the ridge, boat and all, before rolling back down into the water on the other side. The vessel leaves the water completely. For anyone on board, the transition is genuinely hard to process. The boat settles into its steel cradle, the water falls away beneath the hull, and suddenly you're moving over land. The frame shifts and settles on the rails. For a few minutes you're looking at a hillside where a river should be, then the Severn reappears below, and the cradle lowers you back into it. The big chute lifts boats approximately 58 feet and is the only marine railway of its size still operating in North America. The railway also does something a standard lock never could. Because boats are lifted entirely out of the water, the continuous water column between Georgian Bay and the inland lake system is physically interrupted. Invasive sea lamprey, a parasitic eel-like fish that devastated Great Lakes fisheries after entering through shipping canals, can't migrate through a section of dry land. In the 1970s, when plans were floated to replace the railway with a conventional lock, biologists raised the alarm about inland fish populations, and the railway stayed. It moves boats while keeping the lakes on either side protected from one of the most destructive invasive species in the Great Lakes Basin. The Trent Severn still failed to become what its builders intended. The waterway was too shallow for serious commercial freight. The eastern half offered only 8 feet of draft. The western half dropped to 6. Lock dimensions and bridge clearances restricted vessel size further. Boats had to move slowly through dozens of locks, making the route completely impractical for any freight where time and volume were the deciding factors. By 1922, the Canadian Pacific alone was moving millions of tons of freight annually across lines that could handle vessels of any size, in any weather, year-round. The Trent Severn closed every winter. Its 6-foot western draft couldn't carry a serious cargo load, and with 44 individual locks to transit on a single passage, a journey that took days by water took hours by rail. The economics were impossible. The waterway cost more to transit than shippers could justify. The waterway carried some timber, farm products, and local passengers. As the grand strategic commercial infrastructure it had been funded as for most of a century, it simply didn't deliver. The infrastructure didn't disappear just because the freight moved to rail. The dam's engineers had spent 87 years building had done something permanent and irreversible to the landscape around them. Water levels across entire lake systems had been raised. Rocky lake edges that once had no dock potential became usable waterfront. Land that had been too marshy to develop became some of the most desirable real estate in Ontario, and none of it was part of any engineer's plan. The Trent Severn had accidentally created the geography of Ontario's cottage country. The lakes Ontarians vacation on today, the docks they tie their boats to, the water levels they take for granted, all of it exists because engineers in the 19th century were trying to float timber and military supplies through the interior. Small towns that once depended on lumber now depend on tourism. Marinas and campgrounds cluster around lock stations. People travel specifically to the Peterborough Lift Lock and Big Chute just to watch the machinery work. Today, the Trent Severn is a National Historic Site operated by Parks Canada, and the boats moving through its locks are recreational. Pleasure craft, sailing yachts, the occasional houseboat, no cargo. It's also a well-known leg of the Great Loop, the roughly 6,000-mile circular cruising route that takes recreational boaters through the Great Lakes, down the US East Coast, through the Gulf of Mexico, and back around again. The lift locks and the marine railway are bucket list stops on that journey, sought out purely for the experience of them. Something built to move cargo became a reason to slow down. Boats rising 65 feet into the Ontario sky on nothing but the weight of water. A steel carriage carrying a hull over a ridge on dry land. A waterway that connected two Great Lakes and never delivered on its founding promise. The project consumed the better part of a century and over $1 billion in today's money, and the commercial traffic it was built for never showed up. Railways handled the freight. The St. Lawrence expanded for real cargo. The waterway arrived too late and too shallow to compete with any of it. The infrastructure stayed anyway. Every summer, boats queue at Peterborough, cross the watershed at Kirkfield, and ride the carriage over the ridge at Big Chute. The canal nobody needed became the destination nobody planned. What do you think? Does a project like this count as a failure when it accidentally reshaped an entire region's identity for over a century? Share your answer in the comments. Subscribe for more megabuild stories.